Thanks very much. So I've got a bunch of slides I'm going to show today. My colleague Louisa Seers couldn't make it, unfortunately, so I took the train out with Billy No-Makes this morning. But I'm very happy to have a discussion and a conversation. It's quite a small room full of people. So thanks very much for coming, by the way. Whatever your expectation was when you entered the room about what you wanted to learn from me or have a conversation about or input into me, make sure you do it before you leave, right? So if I don't even get off slide 2 or slide 1, but it's what you wanted, I'm fine with that, really. Or if you want, I can just talk and entertain and be whatever, okay? It's a small number of people, so if you have a question, just throw it at me while the question's hot, and I'll juggle with that and try and find you an answer or have a question. Okay, great. Thanks very much. For the sort of agenda we had, first of all, quick show of hands. Who knows what a mainframe is? 1, 2, 3, 4. Thank you so much. 2 more people in the room. Excellent. So mainframe. So I'll cover a little bit about the mainframe, just to kind of level set what it means to me, and then I'll cover who are the Open Mainframe Project, and then I'll have a little bit of a look to the future. Okay. All right. Thanks. And by the way, so I work for IBM. And I often tell people I've got one of the best jobs in the world because I work for IBM, but I really work for the Linux Foundation in terms of they're my kind of sort of spiritual employer. And I've been working on something called the Open Mainframe Project now, probably for about 7 years. Okay. So it's a bit of a level set. I love this. Every time I look up, more people come into the room. This is so good. Thank you so much. So I'll just do a little bit of my. So the first thing I want to level set is if you Google for the word mainframe, you'll probably find something that looks like this. It's the term mainframe computing was coined, I don't know, probably 60 years ago, and it's often looked at as a very sort of old and archaic kind of legacy thing. I like to use the analogy that on the day that the so lots of companies that built mainframes don't exist anymore, and a few do. So Hitachi and IBM and Siemens and Fujitsu. There are Unisys as well. There are companies still kind of extant companies that build mainframe computers. But often the perspective that people view mainframes is of a sort of ancient, dated one, and there is an element of truth in that because the S360 System 36, sorry. The original IBM mainframe computer was created 60 years ago. But then on the same day that it was announced, so was the Porsche 911 car, and the Porsche 911 car still exists right now today, and it's a very modern car. It's a very expensive car, but you can get a fully electric model, and when it came out, it didn't even have electric windows or heated seats, and I'm sure they're the most basic Porsche that you buy right now. So you can still have a really good bit of kit that you evolve and keep up to date with current technologies. One of the other things that there's a lot of mystique about mainframes. Are there any folks in the room who watch Doctor Who or not? Doctor Who, you've got some Doctor Who. There was an episode called Boom in the current series. If you watched it, no, you didn't. Anyway, there was an interesting bit where Doctor Who was talking to somebody, and it's a sort of avatar, spirit avatar of somebody who'd been killed by this kind of evil thing, and he said, "Can you go into the mainframe to solve it?" And so often you see that in Hollywood movies and things. You see people go like, doesn't matter whether it's Tom Cruise or Angelina Jolie. Oh, come on. Sorry, could you not hear me?
For recording.
Oh, for the recording. Okay, sorry. Do I have to go back and do it all over again? Very good, thank you. So you often hear, because I walked away from the microphone. Well, I'm sorry about that. You hear people saying, I hacked into the mainframe, or I'm going to break into the mainframe, and stuff like that. So it has this kind of mystique around it. One of the interesting things about the mainframe is that I go to mainframe conferences, and I still wrestle with people who basically use interfaces like this. This is an interface called ISPF, lets you do file edit on a mainframe, and it's one of the reasons that dates the mainframe is the appearance of the mainframe. If you look at a movie from the 1980s, right, you can date it because everybody's got sort of long, curly permed hair and what they're wearing and things like that. And you can sort of often date mainframe, and it's one of the things that holds it back is how you program it and how you use it. Okay. Anything else you want to suggest to me about a mainframe? Does the word mainframe evoke any emotions in you? Or anything else? No?
Huge big box.
Huge big box is another one that we get, huge big boxes. They're actually quite small. I've got a picture of a mainframe at the back end, an IBM Z16. It's very small. It's smaller than my fridge freezer at home, which might be a reflection of how much frozen food I have and how much stuff I have to throw out to my fridge. The current mainframe, IBM Z16, it has 40 terabytes of RAM, okay, in the default configuration. It doesn't even have to be a mainframe. It doesn't have to be a fridge freezer. You can get a rack-mounted bit that you just plug in now. That's actually only got 16 terabytes of RAM, but that's still a chunky machine, and it can currently handle, I think, 19 billion transactions a second or something like that. So it's a very fast, very secure machine. I'm not here to sell you mainframes, but because
this is really expensive as well.
So let me cover a few points about. So I'll cover that because I do have a thing on expense. So no, IBM. So mainframes are not. So there is a perception that they're expensive, that they're a high cost. They're not. I don't believe they're a high cost. I believe that a single blade model is $135,000, but it generally gets discounted if you're. So most people actually pick it up for like $70,000 or $80,000. That's US dollars. So one of the reasons mainframes account for 3% of IBM's hardware revenue. So it's not a great big cash cow that IBM kind of milks and tries to gouge customers and bleed them dry, even though it may have done that once in the past, but, or may have had that perception of doing that. There is an expense to running a mainframe about the skills required to run it. You can't pick up university graduates very easily, and I'll talk about that later on. And also some of these software vendors, because I think I'll click my next piece of slide, proprietary. If the mainframe, because it's 60 years old, a lot of the software to do source code management was proprietary software, and that meant that a lot of vendors started charging quite high prices. So if you look at the total cost of IT for a lot of mainframe customers, by the way, in terms of mainframe customers, 80% of all banks, I think 75% of all insurance companies use mainframes. It handles 90% of all payment transactions across the world. I just bought a coffee downstairs, Illy Coffee, and I paid for it with a contactless transaction. I think for that transaction to have been approved, it will have flowed through 7 mainframes. That's the rough average for a financial transaction in terms of fraud detection and payment providers and things like that. So one of the reasons that I got involved and one of the reasons that IBM sponsored the Open Mainframe Project was, and I'll click some of these, was to kind of address some of those things about it being expensive and having this proprietary software and not fitting in with modern DevOps and modern Agile. There was this whole movement created a while back called two-phase IT, and it was this kind of slightly weird thing that happened in kind of sort of 1990s to kind of mid-noughties, which is where people would say, I'm going to evolve my mainframe kind of host applications at one kind of speed revolution, and I'll do my front-end stuff faster. And maybe there was a time and a place for that, but that holds you back, right? Because if you're delivering a change set or you want to do integrated testing, or it's nicer if you have the same systems to manage issues, have a single source code manager, a single test tool, again using open source software, you're just better, right? And some of that dragged the legacy. People just started kind of leaving the mainframe because they were saying it's just too slow. For me, I can't evolve the IT fast enough. Cool, thanks for that question. Does that answer whether it's expensive? So, cool, so that's what is it. So, let me just keep a track of time. I'm a terrible presenter for time speaking. So I started at 25, so about 10 minutes in. Cool. Any more questions? Go for it, sir.
I was just wondering, so is it like one way of doing things, on mainframe?
There was, yes.
So it's kind of easier to kind of pick up skills because you just kind of learn one set of skills and.
So your question was about skills. Yeah. So I'll talk about skills. So when the mainframe started, punch cards basically run the earth, okay? and languages like COBOL and things like that. It was before Java, before any object-oriented language was invented. You can do Fortran on the mainframe, you can do PL1, all these languages that, people learned at university in the 1970s, or now they're kind of relegated to history books. They've been replaced with better technology. It predates TCP/IP, it predates graphical user interfaces. Right, so if applications were built without embracing any of that kind of, modern tech and modern form factor, and then they were left alone and left to rot, then yes, the only people who could program that and tune it and do performance analysis eventually just retire out. And I'm loving this conference, by the way. It's the first time I've come to FINOS. I normally go to mainframe conferences, and I feel great because I feel like the youngest person in the room, the youngest person in the conference. I'm not, I'm 57 years old. I'll be 58 quite soon. So, my retirement's not that far into the future, okay? Certainly less than a decade away. And it did cause a problem with companies, and what I often found when I talked to mainframe companies, I spent the last sort of 10 years kind of doing Open Mainframe Project, they would tell me that they could literally spot their mainframers in the cafeteria because they all sat together. They were all, there's a lot about DEI, I'm a huge fan of DEI, but they were mostly old white men, okay? Although, if you look at Hidden Figures, it's a great movie all about the space race and stuff, and you see this 3 phenomenal sort of black African-American women who, and again, they use mainframes. There, so it's not, so there is a lot of diversity within mainframes, perhaps not as much as should have been accepted, but they stayed. And one of the reasons if you think about when Microsoft came along, back in the sort of 90s and basically kind of, won that, and Apple and all those incredible technology that we revolve. A lot of people at companies who were working on the mainframe, who were programming COBOL and Fortran, said, this stuff is cool, it's shiny, it's exciting, I've got mice, I can drag and drop, let's do cool stuff. It's a bit like video gaming in a way. So they rushed to that world, the distributed world. So the only mainframers who stayed were the people who basically liked operating old software. And they stayed and retired out. And you've got this huge skills gap where you've got people who are basically over 55, and then you've got this massive drop because everybody in that middle bit, they went to Java and they went to Windows, and ultimately they all went to Linux. Yeah. So you do end up, so we're really trying to basically feed it from the front, the skills. So it's a huge problem for companies, and I know companies look at mainframe and they say, all of my mainframe guys, they're all going to retire in 5 years. We're toast, basically. So it's a good question.
To be honest, that happens with any random shiny new technology. There's a herd of people who stampede towards the shiny stuff, and then the stuff that's left is tomorrow's legacy, not necessarily because it was a bad thing, but because shiny thing came along and distracted everyone from.
There is, yeah, good question about shiny. So your question was about that happens with every shiny. There is, I look at applications now built using, like Visual Basic or Turbo Pascal or screen scraping tools or some .NET tools now, and I look at them and I think, you're actually put together worse than a 1980s mainframe application. Now you've created more chaos than you solved, because none of the people who built that or provided that know about it, and then you follow Google links to websites that say page expired or documentation disappears. It's a good question.
And sorry to make one more point.
No, definitely.
People never go back to the underlying abstraction of where to get it. I've seen situations where people have put robotic process automation on top of something that they built to be an RPA interface. So if you built it, why don't you just build an API into it? Why? People have a tendency to just layer things on top of
Yeah, so it's a good question. So your question was about
layering the old stuff.
Was about layering and there's a wonderful expression called leaky abstraction. You guys, if you learn nothing else from this session, go buy books written by Joel Spolsky. He's one of my kind of sort of North Star people that I really sort of idolize. And Joel Spolsky coined a term called leaky abstraction, which was at every layer somebody writes something, and the next person that comes along, they don't just actually go back into the original code base and modify that code base to basically, they layer it and they layer it and they layer it. So it doesn't matter how flashy something gets. Leaky abstraction is at some point in time, the underlying operating system or the underlying C driver has to basically just poke its way all through the head, and that's where you get your sort of blue screen of death. So you're kind of like, you must have seen it when you go to a website and the website's all flash and it's built using React or jQuery, and then you just get some horrible little thing with like a stack trace just right in the middle. And you're like, really? You know, and that's an exact example of basically
That's from the Kix database that's abstracted
Prob-
by API server, that's abstracted by web server, that's abstracted by...
yeah, and you're looking at it and you're like, yeah, you must have that all the time with like applications. I know, it always happens, yeah. It's cool. Good questions, by the way. I'll just go back to Open Mainframe. You got another one? Ask it, sir.
The processes 19 billion per second transactions. Is it kind of a lot? How do you put 19 billion transactions per second there?
So the question was about, so you picked up on the 19 billion transaction, which was about 10 minutes ago. I love the fact that you were processing that slowly. So it's a figure, I didn't come up with that figure. So I do know that, so I won't quote any customers that use mainframes, because I work for IBM, and IBM is a very kind of ethical company, so I won't quote a single name, but it's used by huge government agencies. Government agencies in the USA, most of all have got sort of 3 letters behind them, and it's used by every single credit card payment provider. You know, if you select your drop down as to what kind of card you've got, and you go through that list of all of them, every single one of those is using an IBM Z machine at the back, okay? So what we mean by a transaction is that somebody outside that ecosystem is coming in and saying, I want to query this account, I want to query whether this customer is real, I want to query whether this customer is actually, based upon their geolocation information, you know, do you think there's a fraud risk? It might not be them. That sort of thing, you know, give me waiting for that. So each one of those comes in as, and we would call that a transaction. So it's basically an asynchronous transaction coming in, basically. So it could be a query to a database, or it could be a query that actually involves some code, some programming code. Or it could be an update transaction as well.
Is there some kind of custom networking layer across all 19 billion transactions?
Is there some custom networking layer? So it's a good question. You okay if I do this? I'm just taking questions from him. So to get that volume of throughput, so what happens a lot is when you run things on mainframe hardware, you've got completely specialist hardware. It's not based upon Intel. It's based upon custom chips that IBM create. The latest one is called the Talon processor. I don't know what they're named. It's probably named after a Greek god or some, you know, something like that. You know, clever people. Is that where Talon comes from?
Talon, close.
Oh, Talon. Talon.
No.
Talon. The Talon processor, and it has an AI co-processor co-located with it. So what happens is, if you've got lots of individual programs running, like microservices running, needing to do TLS, transport layer security, with like public-private key encryption, that's done by the communications layer. So what happens when everything's co-located on the IBM Z, like a Linux one or a ZOS server, they basically can run without needing to have the software do the private key encryption and the decryption, because that's done by the hardware. So you run it unencrypted, so everything's launched up as HTTP servers, but you still, all of the encryption of the data is done by the hardware at the second it hits the chip. So everything is pervasively encrypted on the chip. So it's a bit like having a graphics card. But anybody who watches a video that's kind of not full screen, you know, your experiences are kind of, you know, pixelated, like the software layer. And the second you full screen it, if you're watching iPlayer or Netflix or something, you're going to have a better experience, right? Because the graphics card is taking over and it says, I know how to do this, operating system, get out of the way. So the pervasive encryption is done on the communications layer. There's a lot of very, very clever things that the hardware people do. Any sort of ranking against AI models as a co-processor, and they literally, rather than having it on the chipset where it's physically like next to it on the motherboard, they physically, you know, they worry about the nanometers, and they actually create custom chips so that they can do AI co-processing. So it's it's built for speed. It's built for transactional speed. That's what it's built for. It's what it does very, very well. Good.
Dart, spear, or missile.
I'm sorry?
Dart, spear, or missile. Talon.
That's what Talon stands for. Thank you so much for your question. But that's a good question. Thanks for that. How long have we got? Are you okay if I just talk a little bit about OMP?
Yeah.
I mean, I can go back. I'll just talk about the intersection between. Okay, so we laid the problems. So Open Mainframe Project. Very quickly, I'll speed up a little bit now. Just going to tell a few stories. So the Open Mainframe Project was created in 2015. So in 2015, and you asked a good question before we came in about, you said, are you a ZOS guy or are you a Linux guy? So the original operating system that was put on the System 360 was called like MVS, and it grew up and it's what's called ZOS right now. It's a ZOS operating system. And there's also Linux was first ported, 64-bit Linux was first ported to the same chipset, that same hardware that I talked about in 2015. But there needed to be a home for it, because a lot of customers looked at Linux, and a lot of other people who built Linux. Red Hat wasn't an IBM company at that point in time, now it's an IBM company. It became an IBM company in 2018, so about 3 years later. And they said, well, we're not going to port to it, we're not going to, because you still own it. Yeah, there's always danger in having one organization controlling something, and there's danger for the user of that, and it doesn't create a diverse community around it. So IBM looked at Apache, it looked at Eclipse, it looked at other open source foundations, and it settled on the Linux Foundation as being the best one, partly because it was a Linux port, but it also did look very seriously at some of the other foundations. So the Open Mainframe Project was created to be the steward on the Linux Foundation of Linux. And right now, I think like Fedora, Debian, certainly Red Hat as well, they're all ported and they're run natively on that hardware, okay? So that's what the Open Mainframe Project was launched to do. And what's interesting is what's happened since then. And I'll talk very quickly. I won't delve into all of these, but I'm just going to point towards the one on the top right, which is called Zowe. So Zowe was because after 2015, a vice president of a very large US bank, about 2016, 2017, she basically said to IBM, we're just going to leave the mainframe, right? And they were like a huge IBM customer, like one of IBM's 20 biggest customers. So it went all the way up to the board, and they met with her, and they said, why are you going to leave? And she said, because all your vendors, she said, my cost is not the hardware, my cost is all of this proprietary software that I have to build on top, and I can't do agile DevOps, and I can't hire people out of college. Fix it, otherwise we're gone. So this project was created called Zowe, and so I was fortunate because I work on Zowe. The purpose of Zowe was to basically address that. So one of the first things we did was we worked with some education groups in the Linux Foundation, and we created a training course for COBOL developers. Really simple, and we also created an environment to host COBOL developers. And then the pandemic happened. So we launched this in 2020. So I was in Dallas, Fort Worth in 2020, and I was literally checking every day whether I could get back in time. If I'd flown back 5 days later, I would have had to quarantine for 10 days. So we just managed to get back. But what happened almost immediately, there was this big issue because the COBOL developers were in massive demand. And I'll click through this, and these are all, they're quotes. US states basically all of a sudden had to provide more support, like big government was needed, right? US always has a struggle between doing more government or less government. They play it out in public in very sort of kind of high ceremony ways. But all of a sudden, if you look at Indeed.com or whatever, they track the number of queries between people looking for jobs, people looking for employers. It's a very kind of Keynesian way of saying, what's my marketplace doing? And there was this huge spike. And there was a need for COBOL developers. Now the course, and it turned into a good news story because basically people had to modernize, coming to your word, and modernize these aged applications that they just turned to rot. And it was a very good story for the Open Mainframe Project and the Linux Foundation because it turned into a success story. There's a joke about, and I told it to you earlier, sorry, you've heard it beforehand, which said, how many COBOL developers does it take to change a light bulb? The answer is none, because they switched it on 60 years ago and it hasn't broken. Right? And there's a gift and a curse in that, because if you haven't touched it for 60 years, then you can't actually embrace modern things like, perhaps running in 64-bit storage or just having REST APIs or things like that. Now, the training course that we created, we created a plugin for Visual Studio Code. And what it does is, do you remember right at the start I showed you this scary green screen thing, right? It basically lets you do all of that through Visual Studio Code. We expected to give out about 400 user IDs. We gave out about 40,000 in the first year. Fortunately, because the system that's backed is an IBM Z hardware in Poughkeepsie, they basically just made it quicker. think I've got 5 minutes left, yeah. So I say it's not your grandparents' COBOL because all of the training is taught through that new interface. It's taught through Visual Studio Code. This is now about 5 years old, this plugin. It's got a lot better. It's currently, we track the downloads of it. It's currently used by 85% of all mainframe shops. I've got little few things I'll click through here very, very quickly. So it's used by, what we found was people who educate COBOL developers all of a sudden were switching their courses. They were saying, this Cameron CA, he's about 70 years old. He's an incredible sort of professor of COBOL in East Carolina University, and I got this quote. He said, thanks very much. His students were, he taught them the way he'd always taught them for 30 years. Then at the very end, he said, now learn it through Visual Studio Code. And now he just said, learn it through Visual Studio Code. So for the last 5 years, there's been this pipeline of developers coming up. People have got badges for it. That's Frank DeMarco, he's the vice president at a company called Kyndryl that does a lot of software and services. What we're seeing at the top is we're seeing, that's for a particular bank, and I didn't have permission to use their name, so I just blotted out who the user is. But even on a public forum, they were saying they just got Zowe with Visual Studio Code working, they went into their bank, they did something cool. It reminds me a little bit, when I was a developer back in the 1990s and Windows 3.1 was coming out, I was working for a company that was using actually IBM OS2 at the time, and you have this grassroots where people are doing stuff at home that they're quite productive with, and then all of a sudden they go to companies and do cool things, and then actually they end up kind of basically knocking out the incumbent the sort of enterprise solution because they can just do things faster. Cool, any questions on that or not? It's basically to address for about the last 5 years, all of the Open Mainframe Project has really been kind of educating and feeding that pipeline of new developers. So I suppose what's next? By the way, you wanted to see how big a mainframe was? Somebody asked a question about that? They still have? That's an IBM Z16. Standing right there.
Wardrobe.
A wardrobe size, yeah. Well, okay, I have a big fridge freezer wardrobe size. Yeah. So a couple of things I want to talk about a little bit. I kind of talk about the sort of future. And one of the first things to kind of break this way of it being this proprietary, awkward, overpriced system you'd be gouged for and you couldn't hire from. So on this, it runs Java, it runs Node, it runs Python, it runs Golang, it runs what you would expect in terms of languages. So it's not, the COBOL Fortran. You don't have to learn how to write Fortran and COBOL and things like that to make it run. Then the next thing that happened was a lot of tools that were on the mainframe became open sourced. So there's a number of communities who already built open source tools. So he built tools on the mainframe that they ended up open sourcing. So IBM did them and a lot of other vendors got together to do it. By the way, the good news story is that that bank that was really angry at IBM and going to leave the mainframe, they haven't left it, and they're actually very successful. They actually became a more successful bank, and they took over 2 of their competitors since they yelled at IBM, which is probably the failure of their competitors. What we want to do for the future, so one of the problems that the mainframe has always had was, do people here, any developers who compile C packages, open source packages? Anyway, you have to compile for S390 and S390X, which is 32 and 64-bit versions. A lot of those communities like Bash and curl and Git and things, they didn't have a system available to test those distributions on. So the Open Mainframe Project provided a system available in the public cloud. So if you're an open source community and you want to test that you run on S390X architecture, you can just apply and we'll give you a free system and give you access to that free system that you can basically test it on, so you can run your DevOps pipeline. And the Open Mainframe Project now has about 90 different tools, which are basically the infrastructure tools like Git and things like that. And actually somebody ported Perl as well, so there are more languages coming in. But the next thing that we really want to do is we want to get more projects. There's a lot of cool projects going on, and I love walking around here and seeing people doing cool stuff with open source. So if you've got an open source project and your financial company, you probably have mainframes. It might make sense if you want those kind of resiliency and that throughput. By the way, the downtime of mainframes is 0.0003 seconds per year. That's the unexpected downtime. So I would need to have 3,000 in a room, of them in a room, and in 1 year, one of them for 1 second might be have an unexpected outage. They are stonkingly reliable. Sorry, that's not a real word, but they are. And that gets better. It's quite sad because that's 8 nines of reliability. A friend of mine bought the domain name for 7nines.com because he's been 99.999999, and he was really happy and he uses it to sell merchandise and stuff. And then IBM said, actually, we've got 8 nines reliability. So that's 8 nines after the decimal place. But that's what we're really sort of trying to do. And you can also, you don't have to buy one of these. You talked about the price. They're public cloud. There are a number of these running on the public cloud, and a number of financial institutions actually just use them as software as a service, right? They basically stick data there and use it. Cool. So very quickly, so mainframes. The other thing is they're very green. There's a lot of really cool stuff at this conference about climate and how important it is that as IT professionals, we don't basically screw up the world for our grandchildren and our children and maybe even us, right? Because things are evolving very quickly. Mainframes are very, very green. In terms of cost, by the way, and this is a weird quote that my manager wanted me to quote, is mainframes account for, I think, 76, so it's 80% of all the world's production data is on mainframes, but it's 6% of the cost, so they are very cost effective. You don't have to buy them, you can also lease them, so that's called CapEx versus OpEx. You don't have to pay it out, you can, anyway. We're trying to make them as open as possible, and that's always changing. Trying to make them as familiar as possible, so people who haven't learned languages like Fortran or learned 3270 interfaces can program them and manipulate them and use modern tools and get away from that two-phase IT and make it so that people can be more agile, and you don't go into a cafeteria and say, that's my mainframe group over there and that's the rest of the world. It just blends, right? So you can have common tools. Cost efficient, trying to make it more cost efficient. My IBM sales team tells me that they are. I still get customers telling me that they're not. So we still have to deal with whatever the challenges are. And it's often because some vendor's got some horrible proprietary old thing in there that they're gouging. You have a question, sir?
I imagine it might be just because the company use it from a staffing perspective, and that's it, because there's so few specialists that get.
It could be staffing, yeah. I talk to university professors and I say, why have you got so many people signing up to COBOL? And they say, because they can walk into a job at $160,000 a year, because that's what the current starting salary is for a qualified COBOL developer in the US, yeah. Because it is a niche skill, and especially now it underpins. And then the word legacy, and cool. Sorry, I just like doing stupid bits of PowerPoint animation. Sorry, I overran.
Presumably mainframes would be cheaper if your font budget wasn't so high.
I'm sorry.
Presumably mainframes could be cheaper if you weren't licensing so many fonts for your presentation.
So your question was, mainframes would be cheaper if I hadn't licensed so many fonts. So all the fonts in here come with PowerPoint for free, and that's I just Googled that image and got it off of Google. You don't have
So all the stuff you've talked about, I'm loosely familiar with the mainframe project,
Okay.
Open Mainframe Project, is getting to put things from elsewhere on top of a mainframe. So the barrier to entry of like, oh, I want to run a web server, I want to run a Tomcat or whatever, you just run.
Okay.
What's your thoughts, albeit in the time frame, of turning the stack, turning the whole premise the other way up and releasing ZOS as an open source thing, so people can, because that would drive education. People can use TSO, they can use ZOS, they can learn it. Someone can access it.
Yes.
There's sort of cloud, free accounts where you can try stuff. Although they're mostly Linux on a mainframe, not ZOS or.
Yeah. So it's a good question. So your question was about open sourcing the ZOS operating system. So there are multiple operating systems that run on IBM Z hardware. There's Linux, and that is an open source operating system, and all of the software for that is, you can just go to github.com/Open Mainframe Project, you'll find all the source code if you want to. And some of the other vendors open source their distribution, some of them don't. It's up to them. So your question was about the ZOS operating system itself.
If I wanted to learn Linux, I don't necessarily need to learn it on a Power 10 or Power 9 hardware on a mainframe video, Z16 or whatever. I could learn that because it's effectively abstracted of the hardware. But if I wanted to learn ZOS and the
So your question was about ZOS. So there are reasons why ZOS cannot be open sourced entirely. So lawyers have looked at this, and one of the reasons is to do with quantum safe encryption. So one of the big challenges, as well as climate, which is a huge challenge obviously for just the planet, but one of the challenges that we all have to face as engineers is that the current sort of Diffie-Hellman, private key encryption, they basically assumed that it could never be broken. And at the point in time that they created it, it could never be broken. There's just not enough atoms in the universe to break it. Unfortunately, that's not true anymore. Quantum computing and the idea that you can just kind of randomly guess the next token in the sequence, basically means that if that private key encrypted data can be busted by computers yet to be built, right? Okay, probably in the next, I think, 15 years or maybe even 10 years or something. And there's talk of the fact that people may have busted it already. So, when do I have to vacate the room? We've got people opening doors. Yeah, and because of that, and because so much banking data and secure data is stored, it just cannot be open sourced. So that's to answer your question. But layers of it are being open sourced, and open source layers are being brought in. So, for example, you talked about somebody talked about web. The whole TCP/IP stack was built proprietary by IBM. It's been replaced for open source distribution. The Git client's been brought in. And so more open source stuff is coming in and basically knocking over the weird bits of ZOS. It didn't need to be weird, but there will always be that layer that talks to the crypto hardware that can just never be open sourced. And even me as an IBM, I've been an IBM for 27 years, I can't even get access to that code, right? It's just too guarded. It's too dangerous.
It would be a good education thing if people could just use it. Because IBM don't make money off ZOS, they make money off ZOS.
Okay, so from an education point of view and just using it, anybody can use it. If you go to openmainframeproject.org, you can just click a button and you will have access to basically a Z system. You'll have a user ID, you'll have a password, you can get a public key and you can use it. There's no problem using it. And if you want, so for the use of it, that is free. Free for education and free for non-production workloads.
Adoption is better than use. People are more like to, if it's free from its shackles, this is why Linux was so successful, because it was...
No, I understand what you're saying, yeah. There is still... No problem.
Thank you.
If anybody wants to go, by the way, you can go. We're just spitballing it.
Can I ask a quick
Of course, you can ask whatever question you want. Thanks for coming to that.
Do you think mainframes will still be around by the end of the century? Or...
The question was, do I think if they adapt and evolve? I think the answer is yes. So the question was, will mainframes be around? And what I see right now with a lot of customers is you always have this dichotomy, this kind of seesaw between things being centralized, between things just being sort of plastered everywhere, right? So when networking came along and when the cloud came along and software as a service and things, a lot of people just splattered things everywhere. I see more things coming back in. So yes, I do believe they will still be around. IBM's been around for 100 years. It'll be around for the next 100. But it started off building cheese graters, right? Things to grate cheese, and people still grate cheese. And a modern cheese grater doesn't look that different than a cheese grater from...
I guess one of the funnest things you can do is actually just get a piece of hardware and play with it. Is there any way to get like some sort of micro cheap mainframe that you can just play with it at home or whatever?
So your question is, can you get a mainframe you can play with?
Without spending tens of thousands.
Yeah, you can. So the model, IBM's current model is what's called a Z16, and it goes all the way back. So I know people who can get Z9s. You can buy them on eBay. I know people who get Z9s and Z10. Actually, Z10 was called a Z194 for some weird reason. Yeah, I know people who do that. A lot of universities have them, and IBM actually does a weird thing where if a bank gets rid of one and it wants to contribute it back to like an academic institution or something fun like that, or like a club or something like that, IBM will actually service it and we'll make sure it's scrubbed as well, because banks often are worried that like, oh, there's something there that we, and IBM will be like, yeah, we'll take it away from you and we'll guarantee that none of your corporate data will leak out. So it's very popular in Germany. Yeah, for some reason the Germans really love mainframes. I don't know. I think the University of Wolverhampton might have one actually as well, and they've got students, and there's a professor there called and they do a sort of hardware course as well, and they do crazy stuff with it. And I think MMU Manchester Metropolitan University might have one as well, and they have a club.
YouTube channel where it was in Germany, like you mentioned it, where they were restoring an old mainframe.
Yeah, there is.
9 or 10.
Yeah, Zeno. Thanks for coming, by the way.
You don't need to check great cheese anymore because you've got cheese as a service. It's sad. Why would you want to have a cheese?
I didn't expect 2 comic jokes from you, but why do? Anyway, thanks everybody.
Thanks.